Let f be a rational function that is graphed in the xy plane. Consider x equals 1 and x equals 7. The polynomial in the numerator of f has a 0 at x equals 1 and does not have a 0 at x equals 7. The polynomial in the denominator of f has zeros at both x equals 1 and x equals 7. The multiplicities of the zeros at x equals 1 in the numerator and the denominator are equal. Which of the following statements is true? So we have a rational function, and we are given some hints about what this rational function looks like. So the first hint they give us was the polynomial in the numerator of f has a 0 at x equals 1 and does not have a 0 at x equals 7. So that means we have a x minus 1 term in the numerator, and we do not have an x minus 7 term in the numerator, because they told us that there's a 0 at x equals 1 in the numerator, meaning the numerator equals 0 when x equals 1. So that only happens is if one of the factors in the numerator is x minus 1, because 1 minus 1 is 0. And since there is not a 0 at x equals 7, there cannot be an x minus 7 term. So that's the hints they give us for the numerator, and this, of course, may be multiplied by something, but we don't really know, and it won't really matter. Then we're told that the polynomial in the denominator has zeros at both x equals 1 and x equals 7. So this means that the denominator has an x minus 1 term and an x minus 7 term. Because if there are zeros in the denominator, that means that when we plug in x equals 1 or x equals 7, the denominator will be 0. And that only happens is if we have an x minus 1 and x minus 7 term, because 1 minus 1 is 0, and if x is 7, 7 minus 7 is 0. And then we're told that the multiplicities of the zeros at x equals 1 in the numerator and the denominator are the same. So that means whatever exponent that we have on x minus 1 in the numerator and denominator are the same. So they could be 3 and 3, 2 and 2, 4 and 4. No matter what they are, it doesn't really matter as long as they are equal. So whatever they are, they're equal. So we'll just say the exponent is just y, some constant y that we don't know. And this just ensures that x minus 1 in the numerator always will cancel out with x minus 1 in the denominator, no matter what the value of y is, since they're both equal. So what could we draw from this information? So two things. First is that there is a hole in the graph. So a hole in a graph occurs when some factor, a 0, is cancelled out in the numerator and the denominator. And the second thing we can tell is that there's an asymptote at x minus 7. Because if there's a 0 in the denominator, then that means that the graph will approach positive or negative infinity as it reaches that 0. Because when there's 0 in the denominator of any fraction, then we get positive or negative infinity. So there's an asymptote here. So there's a hole at x equals 1 and an asymptote at x equals 7. There's not an asymptote at x equals 1 because these two terms are cancelled out since they have the same multiplicity and they're in the numerator and the denominator. So that means that the correct answer is C, a hole at x equals 1 and a vertical asymptote at x equals 7.